Captain Chaudhari. In my series of videos on marine astronomical navigation, I was doing celestial sphere. I had said that in my last video, I had said that the celestial sphere is a sphere of infinite size, which we see around us. You know, the sphere of infinite size is concentric to the Earth. That means the Earth is supposed to be the center of celestial sphere. Or we can say that celestial sphere is concentric to the Earth. Now, this celestial sphere, on the inner concave of this celestial sphere, we find all the heavenly bodies projected. These stars appear to be on the inner concave of this celestial sphere, or the shape appears spherical because we find the stars, we feel that the stars are at the same distance. The moon, which is so close, we feel that it is at the same level as the stars. So moon, star, sun, we find all of them on the inner concave of the celestial sphere. So in the celestial sphere, we find all the objects projected on the inner concave of this celestial sphere, regardless of the actual distance. That means we find them at similar distances, and that's why we call this surface as spherical. Now we assume that the observer is lying at the center of the Earth. He is observing from the center of the Earth. Earth is made up of transparent material, and the observer is able to see everything very clearly. So vertically above his head, he finds the observer's zenith, his own zenith. And everything on the Earth he finds projected on the celestial sphere also, right? And his vision is limited by a great circle on the celestial sphere called observer's rational horizon, whose every point is considered as equidistant from the observer's zenith. Now, as I said, it is difficult to imagine that you are observing things from the center of the Earth, outward. So I gave an idea that we go in outer space, even beyond the observer's zenith, and we look at celestial sphere. Celestial sphere would appear like a dome, this being the observer's rational horizon, and this being observer's zenith we are seeing from top. And all these are the vertical circles. The vertical circles are the great circles in celestial sphere, whose plane is perpendicular to the observer's rational horizon. To imagine vertical circle, I suggest my students they should look up in the sky. They will find their zenith, and assume that you are able to draw a circle right from your left side through the observer's zenith to your right side. This circle has got a plane perpendicular to your position, and this circle is called vertical circle because this circle crosses the observer's horizon at 90 degrees. So how many vertical circles you can have? You can have infinite vertical circles. You can have your own zenith, right? So these are the things which I tell the students that they are their personal properties. Observer's zenith, observer's rational horizons, observer's vertical circle. Now, if we want to see from the center of the Earth, or if we want to see from outer space, then the celestial sphere would appear like this, and we say that we are looking at the celestial sphere. This extreme circle is called observer's rational horizon, and we are looking at the celestial sphere in the plane of observer's rational horizon. This is the observer's rational horizon plane. As far as the directions are concerned, these are the directions: north, south, west, east. This is observer's zenith, and we can assume that we are looking at the dome from top, and observer's zenith is the highest point on the dome, and observer's rational horizon is the baseline. Now, if there is any star over here, if you measure the angle at the center of the Earth, the angle that is made with the plane of observer's rational horizon, this angle is called true altitude. Now, we can also say that true altitude is the arc of observer's vertical circle passing through the star, right? Whenever we refer to vertical circle, we must say observer's vertical circle. We cannot leave vertical circle unattended. it is observer's vertical circle but passing through the star. So here is the arc. Now on this diagram which is drawn in the plane of observer's rational horizon, every diameter that appears in this circle, actually you have to imagine that you are looking at the dome from top, but every diameter that appears is part of the vertical circle. So this star, can be shown here. This altitude which we measured at the center of the earth is this altitude in this diagram. So this is true altitude. And the other side, if we measure the angle with respect to observer's zenith, right? So this particular angle measured at the center of the earth is true zenith distance. So true zenith distance is also the arc of observer's vertical circle between observer's zenith and the body. This vertical circle of observer passes through the body. So this is true zenith distance. Now in this diagram, this is the true zenith distance. Now, if you remember earlier we had said that on the earth, if there is an observer in 30 degrees north latitude, if we have to show this point is 30 degrees north, we will have to draw the equator like this and pole like this. Then only we can say that this observer is in 30 degrees north latitude. And as I told you, celestial sphere can be considered as the projection of the earth itself. Everything on the earth is projected on the celestial sphere. Earth's equator is projected as celestial equator or equinoctial. So if observer's zenith is representing the observer, so equinoctial should be drawn like this, and north celestial pole would be over here, right? So if we have the star below the equinoctial, it looks like the declination of the star is southerly, right? So we will see in a moment what is declination, etc. If we draw a small circle on the celestial sphere passing through the body this way, right? So this particular small circle maintains a constant distance, angular distance from the equinoctial. This is the parallel of declination passing through the star. If I draw a meridian now passing through the body, now this particular portion is called declination of the body, and from here to here till the body it is called the polar distance. So declination of the body can be either named north or south. It can be considered as arc of the celestial meridian passing through the body. Arc of celestial meridian passing through the body between the equinoctial and the body itself. So that is the declination, and the entire arc from the pole till the body, this arc is called polar distance. Now if we look over here, then this is the latitude, so this part should be co-latitude. And here we discover the PZX triangle. Most of the astronomical calculations are done for this PZX triangle, right? We solve this PZX triangle for various problems. So what all things we have understood on this diagram is observer's zenith, observer's rational horizon, right? Observer's vertical circles, the north, south, east, west directions, the true altitude, true zenith distance, polar distance and declination, observer's latitude and the co-latitude of the observer. Now celestial sphere drawn in the plane of observer's rational horizon is one of the most important drawings to do the astronomical calculation. Having said that, in this drawing I now want to define the most important definition, most important term, and please pay good attention, and that is the LHA of the body, local hour angle of the body. The body in this case is the star, and local hour angle is a westerly angle. That means at the pole I am going to describe a circle, but to start, I will start with the observer's celestial meridian and I will first look in the direction of west. That is very important. When I start, I start this way and then complete a circle till I reach observer's celestial meridian. This angle is LHA. Of course, we know this side is west, this side is east, so this angle is EHA. So please pay good attention. This is LHA and the other angle inside the PZX triangle, angle P, is EHA. The diagram could be this way. Once again, the observer's latitude about 30 degrees north, north celestial pole, and suppose the body is over here. And this is the PZX triangle, PZX triangle. This angle is the LHA. So LHA is a westerly angle measured around pole, starting from the observer's celestial meridian till the celestial meridian passing through the body, right? And it is also the arc of equinoctial, the relevant arc of equinoctial from observer's celestial meridian till the meridian passing through the body. So in this diagram, this is the arc of equinoctial starting from observer's celestial meridian till the meridian passing through the body, right? And in this particular diagram, this arc that you see is arc of EHA. If I want to measure the arc of LHA, I will have to start from observer's celestial meridian, go westward and end up the journey here, and that entire arc of equinoctial, that means 360 degrees minus this EHA arc, is the arc of LHA.